Hello everyone, we'll discuss now compressibility. It is one more property of the liquid. We'll see the details. Okay, as far as definition of compressibility is concerned, compressibility is compressibility of a fluid are referred to its ability to change its volume and density when subjected to a pressure. So there are two things. When the fluid is applied with the pressure, it undergoes a volume change. Now what is the relation between the pressure and the volume change? That is what is depicted by what is known as compressibility. There is a term which is defined as coefficient of compressibility. Compressibility of a fluid is a property. What is that property? It undergoes volume change under a pressure. Now, how much it undergoes, what is that exact value if you want to know? Then we define the term coefficient of compressibility, beta with a suffix c, is defined as the relative change of volume or density per unit pressure and is represented as, that is coefficient of compressibility equal to, this is relative change in the volume, that is nothing but volumetric strain, you can say, per unit pressure, means whatever change in pressure that has happened, corresponding to that whatever change in volume that has happened, right? So where dP is change in pressure, dV is change in volume, V of the fluid. The negative sign indicates, here there should have been a negative sign. This term has to be negative. Now why it is negative? Simply because as the pressure increases, the volume decreases. The negative sign indicates that decrease in volume with increase in pressure. In practice, however, the reciprocal of compressibility is beta c. The reciprocal of compressibility 1 by beta is known as the bulk modulus of elasticity, and it is extensively used to characterize compressibility effects. It is represented by the letter K. So the bulk modulus of elasticity K is defined as K is equal to 1 by beta C. Now K represents the compressive stress per unit volume of strain, volumetric strain, because it is reverse of this. So if you say on that top per unit stress, what is the volumetric strain? So since dV by V is dimensionless, the dimensions of K is that of pressure, that is Newton per meter square and Pascal. Now sound is propagated in fluid due to compressibility of the medium. You know that sound travels because of compression waves. So compressibility of the medium, and the speed of sound c is given by c is equal to square root of k by rho, where k is bulk modulus of elasticity and rho is mass density of the fluid. So from this slide, what we understand is what is compressibility, what is coefficient of compressibility, and then what is modulus of elasticity and how the sound propagates. This is called celerity. Celerity is equal to root of k by rho. We'll discuss small problem. Here the data given is liquid with a volume of 0.2 meter cube at 300 kilopascals is subject to a pressure of 3000 kilopascals, and its volume is found to decrease by 0.2%. Calculate the modulus of elasticity of the liquid. We know K, bulk modulus, equal to 1 by beta C. But beta C we have defined as dP by dV by dV. That's why this becomes 1 divided by dV by dP. So ultimately K becomes dP by dV by dV by V. Notice the pressure change. Earlier value is 300. It is increased by, it is subjected to a pressure of 300 kilopascals. Means extra pressure, that is dP, that is 3000 kilopascals. Kilo is 10 raised to 3, pascal is Newton per meter square. We'll see that it is everything is put in Newton and meter square, and its volume is found to decrease by 0.2%. So dV by V is going to be 0.2%. Percent means again 1 by 100. Now if you do all that calculation, it simplifies to 1.5 into 10 raised to 9 pascals. Okay, thank you.